Cadet.
Good evening, sir.
Okay. We are entering a narrow channel, Cadet. Look the echo sounder and check our ground clearance. Check our ground clearance every 4 minutes.
Thank you, sir. Time check, sir. 11:04. Our ground clearance is 40 meters, sir.
Thank you, Cadet.
Sir, time check, sir. 11:08. Our ground clearance is 37 meters, sir.
Okay, Cadet.
Sir, time check, sir. 11:12. Our ground clearance is 30 meters, sir.
Okay, Cadet.
Time check, sir. 11:16, sir. Our ground clearance is 35, sir.
Okay, Cadet. Last.
Sir, time check. 11:20, sir. Our ground clearance is 40, sir. Thank you, sir.
Thank you, Cadet.
Okay, Cadet. We are now entering a narrow channel. Cadet, look at our echo sounder and check our ground clearance. Check our ground clearance, Cadet, every 4 minutes.
Okay, sir. Time check, sir. 11:06. Our ground clearance is 39 meters, sir.
Okay.
Okay, sir. Time check. 11:10. Our ground clearance is 45 meters, sir.
Thank you, Cadet.
Okay, sir. Time check, sir. 11:14, sir. Our ground clearance is 15 meters, sir.
Look at our ground clearance, Cadet. Thank you.
Time check, sir. 11:18, sir. Our ground clearance is 25 meters, sir.
Okay, Cadet.
Okay, sir. Time check. 11:22, sir. Our ground clearance is 30 meters, sir.
Thank you, Cadet.
Thank you, sir.
This is a improvised echo sounder. So let's talk about an echo sounder. What is an echo sounder? Echo sounder is developed in early 1920s. It's invented by a German inventor Alexander Behem in 1913. So what is the purpose of echo sounder? Echo sounder is a type of sonar used to determine the depth of water by transmitting sound waves into a water. It is used to determine the depth of the water along with the speed of sound in water at the time and also called phantoms. So what is a sonar? Sonar is originally an acronym for a sound, navigation, and ranging. It is a technique that uses sound propagation to navigate. There's a two types of an echo sounder. Chart recording echo sounder and the electronic echo sounder. Chart recording echo sounder are specially created with papers held between two rollers moving at an uniform speed over a grounded plate, while an electronic echo sounder is used as a digital method measuring the time delay of return of pulse digital analog display. A lot of vessels nowadays are using an electronic echo sounder, but based on the explanation of our prof, other vessel always have an chart recording for if the electronics echo sounder is malfunctioning, for the malfunctioning of those devices. So let's talk about the components of how echo sounder works. There's an transducer, pulse generator, amplifier, and then the recorder. So basically, echo sounder has the following components. Transducer is to generate the sound's vibration and also receive the reflected sound vibration. So going to the pulse generation, the pulse produce electronic oscillation for the transmitted transducer, and then the amplifier, the weak electrical acceleration that has been generated to receive transducer on the reception of the reflection sound vibrating. And then now they are recording by measuring the indicated depth by the sound, the speed of sound. The echo sounder is using the speed of sound to record or to measure the depth under our vessel. So there's a control here, you can see. Example. So there's a range switch, unit selector, gain switch, paper, speed control for the paper, paper echo sounder that use paper, and zero adjustment, route setting control, fixed event marker, and transducer coverage switch, and the dimmer. So let's tackle the range switch. The range. You can set the range of your echo sounder within between 0 to 50 meters or 1 to 100 meters for your settings. Do you want settings like how deep do you want the clearance between the keel of your vessel to the seabed? So unit selector switch, it's to select the unit fit from fathoms or meters as you required. So this just like an option, like you can set it from fathom or as a meter. The gain switch, that is very important, the gain switch, because in an echo sounder and digital, it's like an ECDIS. If there's a lot of bubbles because underwater, if there's a living creature under the signal that echo sounder brings up the gain, we can adjust the gain to have a clear displacement of or a clear vision in our echo sounder. Then the paper speed control, that is for the paper echo sounder, the speed, how the speed of how the pen to usually speed of available to select the speed to record the meters or the fathoms deep under our keel. And then the fix or event marker. This button is used to draw a line that papers and a mark on indicated certain time. Passing navigation mark. This is very important. When a position plotted the chart, etc. And then the transducer coverage, which has an vessel has more than one switch forward and aft transducer. This is the one of the advantage of having an electronic echo sounder. You can have an forward and aft transducer. So there's no delay in checking the ground clearance between our keel. So let's talk about the errors of an echo sounder. There's 5 errors of an echo sounder. The propagation error, Pythagoras error, false bottom echoes, multiple echoes, and the aeration. So let's talk about propagation error. The velocity of sound increases when the temperature, pressure, or salinity is increased depending on the depth, because we have an only measured depth for the echo sounder. if the seabed is not reachable by our transducer, so there's an propagation error. So if that is the case, we are sure that we are not grounding our vessel. So Pythagorean error. If a vessel has one transducer for transmitting and one transducer for receiving, that's separated by some one distance by traveling by pulse will be generate than depth and seabed shallow waters. So this is the problem of the past echo sounder. There are only one transmitting and one transducer. So there's a delay of receiving or placing to the echo chart, echo sounder. So this is now we have a solution here. That what I said, like we have a forward and aft transducer and transmitter. So there's a two transmitter and transducer of our ship in the forward part and the aft part of our vessel. That is the solution for the Pythagorean's error. So is now very minimal to happen. And then the false bottom echoes in the depth waters, for example. By the time the sounds pulse in return from the bottom, the stylus maybe have already finished more than one revolution of the more false and depth indicated with the much of lower than the actual depth. So this is like when there's an rocky bottom. Uh, there's an there's an rock formation or rocky bottom, seabed, so the different different seabed. So the multiple echoes, this caused by shallow waters, which are rocky bottoms due to the sum of the sound pulse reflect on the down between the ship keel and sea bottom before being record the display. The first echo is the correct reading. That is when you have an multiple echoes. Always the first echo is the correct reading. Remember that. And then the last, the aeration, presence of the air bubbles of the transducer gives rise false echoes. So that is those errors that our echo sounder is facing today. Air bubbles are usually normally caused by vessel goes astern, turbulence with the rudder, a hard over facing vessel's light condition. Those are the simply errors that we can uh, face when we are using an echo sounder.